Bismillahirrahmanirrahim. My name is Sharjeel and my other group members are Muhammad Asif Mukhtar and Muhammad Haris Aftab. And today my topic is softening point apparatus. And the objective of that experiment is is to determine the heat distortion temperature HDT and softening point of polymers using HD and VCAT apparatus. This is the diagram of VCAT and HDT apparatus. Now, what is HDT and VCAT apparatus? The HDT VCAT apparatus is used to determine the deflection and softening point characteristics of all types of thermoplastic specimens. Now, the point is, what is softening point? The softening point is a temperature at which a material softens beyond some arbitrary softness. At softening point, a specific resin flows under given load on heating. There are there are two or three methods available to testing on that method. The first one is HDT, the heat deflection method, or heat distortion test, and the second one is VSD softening point test. The first method is HDT, the heat deflection distortion method. The ASTM standard for this test is ASTM 648 test standard. There are certain pressures which are required for this experiment, which are 0.45, 1.8, or 8 megapascal pressure. Each machine is supplied with AGT test nibs with 3 millimeter radius. The second one is we call VST method, which is called softening point test, VST method. The ASTM standard for this method is ASTMD 1525 test standard. For this test, penetration loads are easily selected via a microprocessor for use with the single loading weights of 10 Newton and 50 Newton. The self-calibration feature of the apparatus ensures that the test results remain accurate.
Assalamu alaikum. My name is Haris Aftab. The topic I'm going to explain is the difference between these two methods. Vikas test is used to identify a temperature at which a needle of specified dimensions penetrate into plastic specified distance. Compared with the heat deflection temperature test, the Vickard test reveals the temperature at which the specimen loses its stability form and softens, while HDT test measures the temperature at which the specimen loses its load-bearing capability. The Vickard point is closer to the actual melting or softening point of the polymer. The Vickard number will typically be higher. HDT is a measure of the stiffness of the material, and as the temperature increases, the two common loads used in heat deflection testing are 0.46 megapascal and 1.8 megapascal. A test bar is molded of a specific thickness and width. The test sample is submerged in oil for which the temperature is raised at a uniform rate at 2 degrees centigrade per minute. The load is applied to the midpoint of the test bar that is supported near both ends. The temperature at which a bar of material is deformed 0.25 millimeter is recorded as the HDT. This is the diagram of apparatus. So, as we can see, there is oil present in the container, and we are heating and a needle, and load is applied on the needle. Factors influencing thermal performance. This test measures short-term performance under load at elevated temperature by measuring the effect of temperature on stiffness, the time of exposure, the rate of temperature increase, and the part geometry will significantly influence the final thermal performance of an application. Factors affecting the HDT method. Extrusion conditions. Higher orientation levels generally lead to higher HDT values. Morphology. Higher crystallinity levels mean higher HDT values. Filler loadings. An increase in filler loadings leads to an increase in the HDT. Now next slides will be explained by my group partner, Muhammad Asif Mukhtar.
Bismillahirrahmanirrahim. This is Asim Akhtar, and today I'm going to present the graph which is about HDT and TG. And HDT is the heat distortion temperature, and TG is our glass transition temperature, R is our melting temperature. So here are some polymers which are shown in the graph. First one is PVC, and second one is PMMA, which is polymethyl methacrylate, and third one is PEEK, which means polyether ether ketone, and the last one is polyesters. And we can see that they are usually have the higher distortion temperature as compared to each other. So ideally, we consider that they have a straight line, but in actual experiment, we don't have the straight line. Actually, we have the experiment which deviates our straight line. So next, we will explain its layout, and here is typically layout of our apparatus, and we can see that there is a vessel and there is a oil in the tank, and in the bottom we have sample test, and we have stirrer, and we also have the temperature, and we have needle and have load on the needle. And after, in the interval of 2 minutes, we observe our calibration, or we can observe our readings on the temperature or temperature scale. And next we will explain some other factors or some other methods which are beside the VCAT method, and these are the ring bell method, Kermer's Sarno method, and Mettler softening point method, platelet stress rheometer test. And next, we will talk about some examples, and these are some polymers which show different softening or heat distortion temperature at the specific load, and which is 4.5 bar, or we can say that 0.45 megapascal. And so next there are some precautions, and during the softening point test, distilled water should be used, and we can also use oil and some other heating materials or fluid. And during the conduct of the test, the apparatus should not be subjected to vibrations. The bulb of the thermometer should be at about the same level as the ring, and there is some personal safety next, and we can explain keep yourself active during the performance. Be careful from short circuits. Avoid drinking any fluid material like oil, HSA. Avoid splashing of oil. Always wear lab coats and gloves. And next, there are some references from which we have taken our data. And and thank you for watching our video. Thank you so much.